Hey everyone, welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. I hope you guys are having a wonderful evening. And we are actually going to be working on linear versus exponential relationships. I have basically like one more day for us to complete our first week of the summer math prep. And so far, I think it's going pretty well. So hopefully people are really getting a lot out of it. And just want to keep things moving. So as I try to get myself together, let's take a quick look versus linear versus exponential. Now, with linear, it's usually going up or going down at a constant rate. So when we're looking at the comparison of linear and exponential, it's really like you're looking at arithmetic versus geometric sequences. So with linear, you're either going up or you're going down at a constant rate. And that's called the arithmetic sequence. So you're basically that constant rate, as some people like to call slope, but that constant rate is called your common difference, okay? So the exponential, that's when you're basically multiplying. You notice that the pattern is being multiplied, or sometimes you notice it's being divided. But if you notice if it's being divided, that means you're multiplying by a fraction. Okay, so you really want to stick with the multiplication because that's called a common ratio, which is geometric sequences. So we're actually going to take a look at certain scenarios and we're going to say, hey, is this linear or exponential? And if we do have some time, which I think we will, we're going to take a little look at exponential growth as well as exponential decay. Now, so let's take a look who's here. Hey, Robert, how are you? Everyone coming on in, I greatly appreciate it. Yes, a couple people joining in, joining out. Oh, Rough Nut, I see you in there. All right, so we got everyone coming in and coming out. Awesome. So let's take a look at our pattern here. So for the first one, we have 10, 13, 16, and 19. So if you notice, it is increasing, but it's increasing almost at a constant rate. And that rate is plus 3. So to get from 10 to 13, I had to add 3. To go from 13 to 16, I had to add 3. Same thing for 16 and 19, I had to add 3. So if my pattern is increasing, and it's increasing at a constant rate, this is a linear relationship. All right. Yes. Hey, Janice. Hey, Danny. How are you? Hope all is well. Oh, Danny. Danny. Oh, Danny. Anyway, here we go. So now over here, we have 2, 4, 8, and 16. So you're like, all right, 2 to 4, that's plus 2. But is 4 to 8 plus 2? Okay, all right, that's all right. So 2 to 4, instead of adding, it's really multiplying. I know I'm using an X. I don't like it, but I have to. Okay, it's a little X. Okay, so the pattern is that I am basically multiplying by 2. Okay, so 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16. So since the pattern was being multiplied, this is called your common ratio. So if we have a common ratio because we're multiplying and multiplying the same amount each time, this is going to be geometric. Okay. First time hearing that? Oh, Yeah, this is definitely on the GED, definitely on the ASVAB. So maybe these are those questions that's going to make us to make that turnaround. Hey C4, how are you? All right. So now, taking a look at this one. So this time we have 16, 12, 8, and 4. What's the pattern? Okay, what's the pattern? 16, 12, 8, and 4. I'm trying, C4, I'm trying. Okay, Pog, hey Pog, you're saying -4. C4, you're saying 4. Okay, you're thinking subtraction. Okay, Chantel, hello Chantel. You're saying a +4. Okay. So if I'm going from 16 to 12, I'm not really increasing. Okay. But if we did 16 minus 4, that will give me 12. Okay, 12 minus 4, that will give me 8. And 8 minus 4, that will give us 4. Yes, so it's decreasing. Okay, so it will be, hello Michael, it will be that -4. Okay. Okay. So we also, even though it's going down, because as I mentioned, linear, it's either going up or down, but it's going down at a constant rate. Okay, so this is your common difference. Okay, common difference is usually represented by the letter D, and common ratio is usually represented by the letter R. Okay, so that means this is linear. Michael, yeah. All right, good, Chantel, there you go. So now, example, we have 90, 80, 70, 60. Okay, what do we have here? What do you think? Okay, oh, Omar. Okay, so we got C4 with -10, Omar with linear, Danny with geometric, Michael with -10, Danny with -10, AMD with -10. Okay, we got linear decreasing. Okay. All right, thank you. Oh. So it is decreasing at a constant rate of -10. So that means 1, this is linear, and we have our common difference. Our common difference is at -10. Okay. Hello, Aaron. Good. Aaron. All right. Elliot, good. All right. So when you're looking at the patterns, okay, I know this time we had 3 of them were linear and 1 was geometric. I kind of threw you guys for a little loop, okay? Because I know most teachers be like, oh, it's linear and geometric. So that means, oh, that one has to be linear. This has to be geometric. Yeah, I kind of threw you off for a loop for a little. Okay? But if your pattern is being multiplied, it's going to be geometric. If your pattern is being added or subtracted at a constant rate throughout, then it's going to be linear. All right, so you also guys asked me for some word problems. Let's throw some stuff together. The same thing I want you to do here is tell me if it's linear or exponential. And you're like, well, wait, how do I know it's exponential? Well, if we're having something that's being multiplied at a constant rate, okay, the same number, that's going to be looking at our exponential. So if we have Tony is buying candy bars for his friends that cost 75 cents each, would that be linear or exponential? Okay. So we got linear for C4. Pog is saying linear. Yeah, you guys can tell me L for linear and E for exponential. Trust me, I know the typing, especially exponential. Yeah, that's too much. Or you could say X like AMD. That works as well. All right, so we got linear, 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 linear. Oh, baby. We have exponential. Dr. I see spots. Linear. Good. Now think about it. For each friend, the cost of that is going to be constant. So no matter what, all right, I got one friend that's 75 cents. And then I'm basically adding another 75 cents for each friend. Okay, so that is going to be our linear function because it's increasing at the constant rate. And since it's increasing at the constant rate, this is going to be our common difference, which is the 75 cents. Okay. Are we back in the 80s? Really? I think we need to go back a little bit further. Because they need to bring the penny candies back. Those were the days. All right. A savings account that contains $1,200 earns 4.7% interest each year, compounded annually. Okay. Linear or exponential? Okay, so Pog is saying expo, Doctor is saying expo, AMD saying linear, Aaron's exponential, Omar exponential, Michael exponential, Chantel exponential, Tamika, hello, exponential, Janice exponential, sorry, thought I was gonna sneeze. It's like, that's the best thing. You can't even see me. So it is exponential. Anytime they mention this terms, compounded annually. Okay. You ever remember that one phrase that someone says, would you like someone to give you $1 million, or they will pay you like a penny a day that's being doubled, something like that. And they will always have like some kind of comparison. And people are like, oh, I want to take the $1 million because I can take all of it. I'm like, well, over time, like we all say, over time, anything that jingles can turn into something that folds. Just give it some time and some space and the right nutrients, if I want to say, the right platforms and everything for it to grow. So this will be exponential, okay? Or I say expo for short. And basically the rate is going to be our common difference. Now, Philip has $500 in his savings account and plans on depositing $40 each month. And I think Elliot is answering this one right now. Okay. Yes, C4, linear, Doctor, linear, Chantel, linear, Janice, linear, Omar, linear. Hello, Misty. Coming in. Michael, linear, Pog, decreasing, linear. Good. Welcome in, Jonathan. All right. Okay, AMD, linear. Good. All right. Any other ones? Okay. Oh, thank Thank you for sharing. Yes. So some people saying it's decreasing, some people saying it's increasing. Which is it? Hey, Chaz. Thank you. Okay. So he has a savings account and he plans on depositing. Okay. Not withdrawing, but depositing. So if he's depositing $40 every month, I know the money's coming out of his pocket. So it feels like it's decreasing, but I guess we're talking about the account itself. So if we're talking about the account itself, that is growing $40 every month. Okay? So this is linear. Bonus points if anyone can tell me what the equation would be to represent that situation. Ooh. Good job, Misty. Yes, increasing. Same month, same money, right? Hey, Creation, how are you? Okay, so Chantel is saying 40M plus 500. Okay. Okay, Michael's saying 500 plus 40N. Okay. Can I make the assumption that M and N is representing months? Okay, missed it. Okay, so what we're doing, Janice, is we're actually creating an equation for this situation. About Philip was 500 in savings account and plans on depositing $40 every month. Okay, N is months. Okay, M is months. Okay, thank you. Not a problem. Yes, months. Awesome. So I'm just gonna do an M or N. Yeah. All right. All right. So Pug is saying $500 minus 40x. Okay. Oh, here we go. Sorry, Doc. I almost skipped you. It's 500 plus 40 times 12. Okay. Okay. So Pog, why subtracting? Okay. AMD. No. For the next one? Not for the next one, AMD. Okay. So why subtracting? Exponential. Okay. All right. So we started out with $500. So that's like your y-intercept. So if we think of it as a savings account and he's depositing, so that will be plus 40 and then our variable, which could be M, it could be X, it could be anything. Now, if we're thinking about his pockets, that will be subtracting. If we're thinking about Philip and how much money he has left in his wallet, I would do subtracting because since he's giving the money away, that would be in the negative. Okay. I think this one is referring to the accounts, but again, if it doesn't say it, how would you know? Right? All right. Can't see. Oh, sorry. Thank you. Okay. Right. So if we're going into the account, so the 12 is going to represent the month, but that might be his plan is to deposit $40 a month. Maybe he only does it for 10 months. Okay. But since we don't know the exact month or how number of months, we just use M as our variable. Okay, you're welcome. All right. So now, every time, I'm going to slide over. Is that okay, Doc? All right. So every time Robert gets an A on this math test, his parents gives him $10. What do you think? Every time Robert gets an A on this math test, his parents give him $10. So C4 is saying linear. Doctor is saying linear. Okay. Hey, TK. Okay, Michael's saying linear. Okay. All right. Elliot's saying linear. All right. Hello, Nicholson. How are you? All right. So this is an actual thing that's going on. If for people that don't have kids, or maybe they have kids and they don't really go too crazy with allowances. I know kids that will get $100 for every A they get. I don't know. I don't know when that started, but here we go. But so every time he gets an A, he gets $10. So maybe he's constantly giving me A's. Okay. So that is going to be at a constant rate. So that, yes, is linear. All right. And what would the equation be for that situation? What would that equation look like? Same money for same A. Right? Crazy. I know. Okay. X plus 10. So Pog is saying X plus 10. What do you think? I see, just give a test daily. Exactly, right? Are we having a test today? Can I put my name down? Okay, so now I'm seeing 10x. I'm seeing A times 10. I'm seeing A plus 10. Okay, so it seems like, okay, Michael is saying 10x. Okay, Dr. IC Spot says A plus 10. So it seems like there's a difference going on with the operation. We know that it's either A plus 10 or 10x or 10a. All right. So let's take a look at this. So that means, let's say he's got, do a quick little graph this way. So this is going to represent the A's, and down here is going to represent the money. So when it comes down to, so he gets 1A, that means he makes $10. Say he has 2 A's, so that means he's making $20 total. 3 A's, he's got $30 total. Even if I go up a little bit more to 4, that means he would get $40 total. So in order for me to figure out what's happening, remember your slope, if I may, or the rate of change, is like what's the difference between the money and the number of A's. Okay? What's going on between the money and the number of A's? What's the pattern? Take a look. What's going on? Okay. So if I have like the change of y over the change of x's, it seems like I'm adding 10, but in reference to the A's, I'm looking at 10 divided by 1, 20 divided by 2, 30 divided by 3, 40 divided by 4. So the same rate of change is 10. So we're looking at y equals 10a or x. So that means for every a, I get $10. Okay, so it's not addition, it's actually multiplication. You're multiplying, yes. Okay, so you're going to be multiplying, not adding. Okay. Okay. You did it correctly. Good job. All right, so this one I'm going to have to unzoom quite a bit. So we looked at it as a bunch of numbers. We looked at it as word problems. Now, let's look at it as a table. So we looked at it algebraically. We looked at it verbally. Now we're going to look at what's called numerically. So it's going to be really, I'm going to try my best to get it all or most in the camera. So if we notice, my x values is on top. The y values, or the function of the x, is down underneath. So we want to know, is it linear or exponential? So don't forget, let me slide back down again, or up. So don't forget, linear, you're adding or subtracting at a constant rate. Exponential, you're multiplying. Okay, even if it feels like you're dividing, you're really multiplying by its reciprocal. So if I take this first one, we have 1 5, 2 10, 3 15, 4 20, 5 25. Okay, you can't see the 525. There you go, 525. So what's happening? What's happening with the patterns? Okay, so C4, you're saying linear increasing, or you're saying now multiplying by 5? Okay, which one? You're saying multiplying creation? Okay, so multiply by 5, 2 times 5. Okay, so you're saying multiplying by 5. Okay. All right, multiple. All right, so let's take a look. So my x values are increasing by 1. Okay, you got 1, 2, 3, 4. But my y values is 5, 10, 15, 20, 25. So there's a pattern. Okay, there's a pattern. So if I multiply by 5, that means 5 times 5 should give me 25. Why is there a 10 there? If 10 times 5 should give me 50, why is there 15 there? If I do 15 times 5, that will give me what? 75? But there's a 20 there. Yes. There you go, C4. So from 5 to 10, we had to add 5. To 10 to 15, we have to add 5. 15 to 20, we added 5. 20 to 25, we added 5. So since the pattern is plus 5, this one is going to be linear. Okay, so it's going to be linear. The reason why I had you guys do the multiplication or the division from the last one is to show you where your slope is coming from. Remember, your slope is your change of y's over your change of x's. So 5 minus 1, that gives me 5. 5 divided by 1 gives me 5. 10 divided by 2, that gives me 5. 15 divided by 3, that gives me 5. 20 divided by 4, that gives me 5. 25 divided by 5, that gives me 5. But when we want to figure out if it's linear or exponential, if your x's are increasing at a constant rate, let's see what the y's are doing. And if the y's are adding, it's linear. Or if it's subtracting, it's linear. If it's multiplying, that's when it's exponential. Okay. Oh, okay. Yeah. No, we're not doing that part. Okay. But we multiply. All right. So now, okay, so we see y. Okay, so this is actually going to be linear. So now for the next one, we have 1, 0.25, 2, 0.5, basically, 3, 1, 4, 2, and 5, 4. Okay. So C4, you're saying this is linear. Okay. Then what's my common difference? And then doctor, you're saying it's exponential. Pog, you're saying exponential. Okay. Okay, now you're saying multiplied by 2. All right, so we have exponential. Okay. X's are increasing. There you go, doc. Okay, X's are increasing. So that means I need to take a look at our Y's. Okay, so from 0 to 0.25, I mean 0.25 to 0.50, then 0.50 to 1, but then it goes 1 to 2 and 2 to 4. So if I look at 0.25 or 2500ths, that's equivalent to 1/4. 0.50, that's equivalent to 1/2. So in order for me, sometimes people don't see it right here, but they might see it here. So in order for me to go from 1/2 to a whole, that means we had to possibly do some doubling, because 1/2 times 2 will give me my 1. And then 1 times 2 will give me my 2. 2 times 2 will give me my 4. Okay? Because if I doubled 1/4, that will give me 2/4, and 2/4 reduced will give me 1/2. Okay? Got it. Good. So since we're doubling, like you said, we're doing an exponential. Okay? And then my common ratio is going to be 2. Whereas my common difference from the last one, which I forgot to put down, which is my 5. All right. Okay, see if you can do the last one or the next one. So it's 0, 800, 1, 400, 2, 200, 3, 100, and 4, 50. Okay. Hey, JB, how are you? Okay. All right, I'm getting one of two answers. So we got linear that's decreasing, or exponential because we're dividing by 2. Okay. All right. So then let's take a look. If I were, say, decreasing, for me to get to 800 to 400, I would subtract 400. But if I tried to subtract 400 with this 400, I'm going to get a 0. But in actuality, I have a 200, a 100, and a 50 waiting in the wings. So it's not going to be a consistent decrease. So when it comes to it, for me to go from 800 to 400, a lot of people would say divide by 2. But when it comes to the geometric function, it's not division. It's going to be multiplication. So what is my common ratio? Because we all agree it's exponential. So if it's through multiplication, you guys notice that you were dividing by 2. So if I'm going to flip the script and I want to know what is the pattern, there we go. Good, Jazz. Good, Pog. Good, Chantel. Good, Doctor. There you go, Jazz. There you go. Okay, multiply by 1/2. Yes. Okay, when you multiply a whole number by that fraction, it's going to get smaller. And that's what's happening here. So we're not dealing with that. We're multiplying by 1/2. So 800 times 1/2 will give me 400. 400 times 1/2 will give me 200. 200 times 1/2, that will give me 100. And 100 divided by 2, that will give me 50. So that means we have a common ratio of 1/2. All right. How are we feeling? Okay. I was in school. We're probably classmates knowing us. Right? But see, now you get to like relax and just do a little bit of math, unwind a little bit. Yeah, okay, good. That's it. That's perfect. I love when people are like, I just want to study more. And that intrigues me. That really inspires me. So thank you, Chantel. Thank you, everyone, for showing up and staying here and doing so much. I appreciate y'all. All right. So, one more concept that I want to do, and then we're wrapping it up early because it's been a day. All right. I know. I feel like every day has been a day for forever. And I'm like, when am I going to actually find my joy? That would be so nice. All right. So we have exponential growth and decay. And now I know I've seen some of these before. We worked on it when we were using this equation where it's like a times b raised to the x. Sometimes it's written like this. Okay. But now we're doing some expansion on that b. Okay. We're talking about growth when it's like over 1, and we're talking about decay between 0 and 1. All right. So when they give us like not really simple interest, okay, but when they give us like growth and decay problems, we should be referring to this. Now, there is an expansion off of these, well, especially this one. There's an expansion off of this formula, especially when you're doing compound interest. So you have to incorporate like the number of times it will be compounded through, like, say, an account. Is it annually? We kind of mentioned that in one of the problems. If it's annually, that means it's happening once a year. If it's bi-monthly, it's happening twice a month. If it's bi-weekly, it's happening every other, well, like for 2 weeks in the month. So it's not back to back. But these are the things. And I want to kind of show just a little bit, and then we are done. So I was trying to fit the word problems. That's the only thing. Word problems, I love doing them, but they don't fit my book. So we got to make all kinds of special arrangements. All right. So now we have a $500 investment, increases 6% each year. How much is the investment worth after 17 years? Okay. And we need to round our answer to the nearest cent. All right? So, couple things is happening here. All right? Nope, we're not going to hate them. We're going to take them step by step. All right? So we're going to tackle it. We're going to face our fear. Why do I feel like the 300 right now? Let's go! Here we go. So we have a $500 investment. That's important. Okay? So this is what we started with. And it increases. That's important. So increases is telling me what type of function we're dealing with here. We know it's exponential, but it kind of tells us which type. Then this 6%. That 6%, that's our rate. So then we're looking at how much the investment's worth after 17 years. That's important because that's our time. All right, so just, let me see if I can just focus right here and zoom a little bit. Because the other part of the sentences we don't need. What we need is what's highlighted, and it just fits right there, which is beautiful. All right, so now, since they said that this is an investment that increases, that's telling us that we're dealing with growth. Okay, so we're dealing with growth because they're telling us it's increasing. Now, the starting value is what? What's the starting value? Good, JB, good, Michael, Pog, AMD, you're giving me that part, but tell me you're telling me my rate and my time. So what we're starting with is, nice Chantel, good, the principal, yes, LB, yes, the principal. So what is my principal? It's that $500. That's what we started off with, okay? So if we're starting with this $500, now that growth, because since we're talking about growth, it's going to be a growth rate. And if you recall, inside that parenthesis, let me see if I can write it right here. So it was P parenthesis 1 plus R raised to the T. Okay. Hello, General. How are you? All right. So our starting value, that's going to be the P. The growth rate is what's happening inside that parenthesis. Okay. So it's going to be 1 plus that percent as a true decimal. I'm okay. As a true decimal. So what's 6% as a decimal? There you go, Chantel. Good. And there was someone else that had that there. AMD had that section there too. Good, Michael. Okay. Yep, altogether it will be that 1.06. And my rate, yes. So here we have 0.06. If you think about it, 6%, it's like 6 cents. So if we're looking at that growth rate, we got our 1.06. Okay. So when it's the growth rate, it's the whole entire thing. All right. So now let's plug this stuff into our formula. So, sliding over, we start off with the 500. Okay, that 500 is going to be times to our growth rate, which is 1.06. And it's raised to the t, which our time is going to be the 17 years. Okay. So it's not monthly. It says each year. Okay, each year. So it's similar to what, who just wrote that not so long ago? AMD. Okay, similar to what AMD was saying. Now, this part here, and this was what gets everybody. They always want to say, okay, let me multiply 500 to 1.06, and then I'll raise it to the 17th power. No, you're trying to get arrested. Okay, so, oh, where's my money? I'm like, no, it's not that far. No problem. All right, so you have to think about PEMDAS. Okay, we have to deal with our exponent before we deal with multiplication. So we will have to raise, okay, that 1.06, we need to raise that to the 17th power. Let's see if I can get it kind of in here. Or I might have to do it like this so you guys can see it into the light. Oh, there we go. Out to the light. Okay. All right, so 1.06 raised to the 17th power will give us 2.69, 2772. Okay. 786. Right? And then we multiply this by 500. Good. So then this is that total amount. So $1,346. Now, they want us to round to the nearest cent. So it's not going to be this whole thing as my answer. So since we need it to this, to the 100th spot, we need to look at the 1,000th spot. So if it's 5 and above, we're going to give it a shove and add 1 to the 8, which it is. 5 and above means 5, 6, 7, 8, 9. Okay, so that means I'm going to add 1 to that 8, so it'll be 39 cents, just as Michael has it. And that's what you got? Good. Ashton, good. Okay. Okay. So not 0.9. Okay, 39. Okay, I got scared for a second. I'm like, whoa. Okay, gotcha, Janice. Good. So then that's your answer. All right, last one. Then we are done. I just do this instead of like feeling like I'm off the edge a little bit. All right, so a new SUV purchased for $34,500 depreciates 13% each year. Okay, what is the SUV's worth after 6 years? Round your answer to the nearest dollar. Okay, so notice how I'm taking my time reading the word problems. I know during the test you're just going to be like, blah, 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 blah. What do I got to do? All right, and you're like, okay, what's important? So first off, I see that the 34,500. So when they're talking about depreciating, like when you buy a car, regardless of whatever, you just bought it off the lot. As soon as one of the tires, not all four, as soon as one of the tires gets off that lot, you could be driving sideways. As soon as it touches the street, depreciation, boom, hits it. Okay, so whatever you just paid for it is no longer worth that anymore at all. So all four tires don't have to hit the road, just part of one. I know, it's crazy. So other part depreciates. So for us, wondering like, what does that mean? Okay, it's basically going down. The value is decreasing. And they're telling us the rate. The rate is at 13% each year. Then they want us to find out how much the car is worth after 6 years. So, since it's depreciating, it's going down. So that means if it's going down, we have a decay. All right. So if we recall our formula, I can put it right here. The only thing that changes is what's happening inside the parenthesis. For growth, it was a plus sign. Okay, because you're growing, you're expanding. For decay, it's going to be a minus sign. Okay, that's the only difference of the two formulas. So if you notice that they say the word depreciation or the value is going down, okay, anything that's referring to the word down, action, all that stuff, that means you're looking at a decay. But if they're saying something is growing, something exceeds, something's increasing, that means we're dealing with growth. And it'll be a plus sign. All right? Right? I know, that's what I'm saying. That's why I bought my car for, and mine's a 98. Can't get it like that anymore. So, the starting value is the starting amount. So the starting amount was 34,500. Okay. And since it is decay, so the decay rate, that's going to be 1 minus your percentage, which is 13%. So 13% as a true decimal is 0.13. So now all you have to do is just basically subtract. So that gives you 87. This is 0.87. So now we just have to plug it into our formula. So the starting rate then inside your rate you got 0.87. And then how much is it worth after 6 years? So your years is your exponent. So as we done before, we will do it again. So first we have to take our 0.87 and raise that to the 6th power. Can you guys see? Okay, you can see now. And then we're going to multiply that by 34,500. Okay. And we're rounding to the nearest dollar. Okay. What would this be rounded? Oh, sorry. I'm blinding you guys with my light. What would this be rounded to the nearest dollar? I know, right? There we go. Okay. All right. Okay. So since we're rounding to the nearest dollar, this is where that 0 is. So not to the nearest thousands, just to the nearest dollar. Okay, good. All right, good, Aaron. Good, BB. There you go, JB. There it is. Good, Michael. Good, C4. All right, awesome. So we have 14,000, right, in 6 years. And you're probably still making payments on this thing. All right. Okay. So that's basically looking at exponential and linear. Okay, linear, you would increase things at a constant rate. Okay, exponential is usually dealing with the multiplication. Now, if I were to basically graph or to tell whatever the pattern, the ones that was like multiplied, that will be my B. The A is your y-intercept, where you start. So like if I were, and this expansion of that, if I were to graph this investment one, that means I will start at 500 on my y-axis, because that's the amount that we started to bring to the investment. Okay, same thing if I was buying the truck. Okay, got the SUV, I came in there, with $34,500, and that's what I started with before the depreciation occurred. Okay. And since our time, a little schmear. Since our time was 6, because it's on the tape. So that's what's happening each year. So that's the 6 took care of the years that we're talking about. Okay, C4. Okay. So then that's how much it will be for that. All right. Okay. So that's what we got for tonight. I want to, for tomorrow night, because I have a very interesting session a couple days ago from a gentleman that's trying to become an electrician apprentice. And he gave me one of his practice tests. And I'm like, for real? It was like very interesting. It was a lot of the concepts that we'll see on the GED and the ASVAB, but the way it was presented, it was just very interesting. So I'm thinking about presenting that to you guys. Because one, I know there's a lot of you guys that are still or starting to do college courses, and I really want to support you. At the same time, I don't want things to be too stagnant with us, but I don't want to go completely over you guys' heads by like, hey, let's do some Algebra 2. And then you're going to be like, what the heck is this? Right? But it's very interesting. It's very interesting to see like some of the twists and turns that they have to do. And he was like, if you weren't with me, I would have never known where to start. And it's just very interesting. So I'm going to set that up for us for tomorrow night. I can't believe it's Thursday already. Good gravy. So yes, so we will be on tomorrow night at 9:30, and I'm going to pull a couple of those examples. So if you're knowing anyone that is trying to get their GED, their ASVAB, maybe even the TEAS test, please send them my way. Or if they're currently taking a class and you're like, yeah, my class is way hard, please send them my way because I need clients. I really do. So if anything, all of my lives, if you ever want to follow along or maybe see the replay, my live replays are on my YouTube channel, okay? ACG Math Tutoring. But then here are some people here on TikTok that you guys really should be following. So again, I know a lot of you guys are like, yeah, we go this every time. So if you're thinking about nursing and trying to figure out the dosage calculations, Blessed RN is a perfect fit. Then we have Impact Math with Miss Taylor for TEAS, ASVAB, and GED. She's on during the day. So if you just like, you know what, Audrey, I love you, but this 9:30 stuff is killing me. Hey, please let me know. And you can definitely go and watch her lives. And sometimes she comes in the evenings, but her evening ones are for subscribers only. Okay, but her morning or I want to say early afternoon is her freebies. So if you're looking for a chemistry tutor, Professor TK is here. If you want to learn how to add, subtract, multiply, and divide using the abacus, learning with Lynette is amazing. If you have some kiddos that are thinking about, you're thinking about homeschooling for next year as opposed to putting them into the classroom and you need some assistance with that, or maybe you're homeschooling now. Anyone that's pre-K or kindergarten, you can follow my girl Nancy, or online elementary tutor. And as well, Robert, who is here, the AP Statistics, also AP Calc, that's AB or BC, if they know somebody that's about to do that, I don't know, like next year. If anything, reach out to him. Like I always say, I don't do that, but I got a guy. He's the guy. All right, so follow Robert, the AP Math guy. Definitely will be able to help you and to achieve so you can get that score, so you can get that accreditation. So it's definitely the person to do. How about college? Well, I tutor college. Like, what are you doing? What's going on? Today through email. I think I did already, but I will try again. Hey, good evening. I think I did message you with the stuff, but if anything, through Messenger, just send me your email again. I think I did. So, Sir Martin, college, what are you taking? Okay, Adventure, how are you? Yeah, because I have been tutoring a couple college students. We're starting to do that elementary statistics that I loathe so much. But if anyone that's taking intermediate math, please let me know. Yeah, we'll just keep it at that for right now. All right. Okay, Calc 1 and Calc 2. Okay, that's not me, so that will be Robert. Okay. So make sure you reach out to Robert, the AP Math guy. Okay, he just started his TikTok last week? This week? I don't know, some kind of week. Days are just flying by. So if you're looking, you're like, oh, there's not a lot of stuff going on. He just started his TikTok, but he is very knowledgeable in that. Okay, definitely, Mark. Not a problem. Okay. Yeah, I tried to associate with people that can help you out. So if you're even thinking private tutoring, my math notebooks, this notebook I actually designed, this and a couple other covers. So the one thing about it that's different, on the back I actually have resources that you can use for your classes. This book is actually designed for grades 7th grade all the way up to adults. So if you're like a college student and you like to have your things a little bit more organized, so if anything, you have like some of your dots on one side. I like the dots because it makes graphing so much easier. But I also have the grid side as well. Then you have the formula section. You can write your steps that help you down. Then you can also do a mood tracker. This is great for teachers. I know we're finishing up the year. I think Baltimore City is done next week. I know. Some of you guys have been on summer vacation for about like 3-4 weeks now. We haven't even done yet. We're not even done. It's crazy. All right. Yep. There you go, Martin. There's Robert right there for you. So go and chit chat. All right. Yes, of course. Well, for me, I'm hoping other people do it. That's nice. But for me, I like to share greatness. When people are really good at something, why not? I can't service 1% of the world's population, but I know I'm not good at everything. I know my weaknesses. I know my strengths. My strength is like Algebra 2. Like, you can't touch me on that. So I can break that stuff down. Geometry, to an extent, I hate proofs, but I can suck it up and deal with it because you can do proofs multiple ways. And some teachers like, oh, I want it done this way. And I'm like, okay, did I know that? No. So how was I supposed to know that? All right. Oops. Okay, so I guess they're ending my live in the next couple minutes. So, all right. I'm going to just refer it and break it on down. This is the way this day's been going. All right. So if you are interested in purchasing my notebook, it's also in my TikTok shop. I just opened that up. But if you want to, you can go to my website. That link is actually in my bio. I know they don't like us to say that, but that's where it's at. I mean, it's highlighted, where else am I supposed to say? But for the most part, if you need any assistance, okay, here we go. If you need any assistance, just let me know. Sorry, I gotta get this little puzzle piece in there so I can see you guys. There you are. All right. So if anything, please do not hesitate. If you're a tutor and you want, please do not hesitate. If you're a tutor and you want to learn how to advance in your tutoring business or just to brainstorm, I am doing that as a service as well. So please let me know. All right. Okay. Life. Okay. I just have to figure something out. Okay. So I will let you guys go. Have an amazing evening. Please be safe. Be careful. Yeah. Baltimore is starting to get a little hot. I finally had to put the air conditioner in. I know, more money, but here we are. All right, guys, have a lovely evening, and I will see you tomorrow night. And I'm going to try to put those questions together for us. All right, talk to you soon. Bye.